Hello, geometry. Today we are talking about section 10.4, angle relationships in circles. So this is coming off of, or continuing on from, inscribed angles and inscribed arcs, what we were working with just the other day. But now specifically we're talking about if we have tangent lines and chords. So tangent lines and chords working with it in my circle. And so if we're given some information, such as that this right here, I will call angle 1, and opposite it is angle 2. The same relationship between inscribed angles and inscribed arcs is applied here. So if I were to look at angle 1, it is referring to, or it's working with this arc right here, all the way around. And angle 2 is in relation to this arc here, going all the way around. And so taking a look at 1 and 2, I can think about and learn a couple things. First of all, since the tangent line is a straight line, I know that angle 1 plus angle 2 must equal 180 degrees. Again, that's because this tangent line, we can name it here, we could call this AB. So tangent AB is a straight line, and therefore angle 1 and angle 2 have to add up to be 180 degrees, because again, in geometry, any straight line you can assume is 180 degrees. Well, now if we're thinking about, okay, with inscribed angles and inscribed arcs, as we were working with just the other day, I'll label this a little bit more. Let's call this CD. Actually, I'll add a little point here just to help. So if I'm talking about arc CPD, I know that this arc is equal to 2 times whatever angle 1 is. 2 times whatever angle 1 is. So if angle 1 and angle 2 add up to be 180, then I know that this entire circle here, as it always does, adds up to be 360. So another way that we could have written this is maybe backwards. Angle 1 is equal to 1/2 CPD. And again, I'm going to add another point over here just for clarification. So let's say F. And also 1/2 of arc CFD is equal to angle 2. So again, this relationship is very similar, if not the same concept as with inscribed arcs and inscribed angles, which was 10.3. So let's try another example. Let's say we have a circle here. Tangent line and a chord. Not necessarily drawn to scale, and we can pretend that chord goes all the way across. So if I was told that this is angle 1, I don't know the measure of angle 1, and let's see, I have A, I have B, and I have C. And I'm also told that arc ABC equals 150 degrees, then I'm asked the question, what does angle 1 equal? And so again, if ABC is 150 degrees, then I know that angle 1 and arc ABC relate in this regard, that 1/2 of arc ABC is equal to angle 1. So therefore, if I were to plug in ABC, 1/2 of 150 degrees equals angle 1. Therefore, angle 1 equals 75 degrees. So again, this is the same relationship that we had just looked at with inscribed arcs and inscribed angles. Now let's say we're given a little bit of other pieces of information this time. So again, we have a tangent. Seems easiest to draw them right there, along with a chord. This time it went through the triangle, but that's okay. And I have A, B, C, and D. I'm told some information. I'm told that angle CBD equals 5x. And so again, that angle that we're talking about right here is this whole piece. CBD equals 5x. And I'm told that arc DAB equals 9x plus 20. And I'm asked to solve for x. Figure out what x equals. So again, DAB is this whole arc over here, and it's 9x plus 20. And this angle right here is 5x. And so I need to set up a relationship between these two values that I've been working with or given. So I know that the angle is equal to 1/2 of the arc. Again, the angle, which is 5x in this case, is equal to 1/2 of the arc. I need to solve for x. Instead of distributing 1/2 into the 9x plus 20 quantity, I'm going to actually multiply both sides of my equation by 2. And so here I have 10x equals 9x plus 20. Subtract 9x from both sides, and x equals 20. The algebra wasn't too difficult, but we solved that x equals 20. Now, let's just plug it in and make sure it all makes sense. So if x equals 20, then really this angle here should be 100 degrees because it's 5 times 20 is 100. And if I plug it in here as well, again, my answer should hopefully come out to be 200. 9 times 20 is 180, plus 20 is 200. And so this entire arc, DAB, would equal 200 degrees. And so again, it's twice the size here. All right. This next piece is new as well. Just going to take it right here in the middle. And we have a tangent line, continues on in that direction. We're going to assume that just barely tap that right there. And then I have a tangent line over here as well. So it intersects the circle, or just taps it and continues on at point P. I have point Q at end of the circle, and I have point R right here. And so now I want to give you a new equation that we can use, or formula, in order to solve for a couple new pieces of information. So let's say that, again, we'll call this angle A, and we want to figure out how angle A would relate to these other arcs that are working around. And so I'm actually working with two specific arcs. I have arc PQR going here, and I have arc PR. And we know that PQR plus PR is going to be 180. And so that's going to be helpful in a couple of situations where we might be given PQR and not PR, and so forth. And so we'll need to solve for one or the other. So the formula here that we're going to use is that the measure of angle A is equal to 1/2 the measure of arc PQR minus the measure of arc PR. So the angle A is equal to half the amount of the outside arc minus the inside arc. That's what I like to call them. So again, here's my inside arc because it's within both of those tangents. It's closest to the angle that we're working with. And then I also have the outside arc, which is furthest away from the angle that I'm working with. Then I'm going to give you one more equation you might need to use. We're given some chords. Okay. Let's talk about angle 1 and angle 2. Now again, use some previous information. If these are chords, which means they're straight lines, then I know that 1 plus 2 has to be 180, so that might become useful at some point. But let's say I have A, B, C, and that's D. And again, something that might become helpful is you have the measure of angle 1 is equal to 1/2 the measure of CD plus the measure of arc AB. So again, speaking of angle 1 right here, we have measure of CD plus AB. And then the next equation, very similar, is if I'm talking about the measure of angle 2, it's equal to 1/2 the measure of CB, arc CB, plus the measure of arc AD. Alright, your homework for this lesson is page 624, 8 through 26. 8 through 26. If you have any questions, please email them to me. Submit these in the homework drop. Thank you.